Hi, today I'm talking about LeetCode problem 22, generate parentheses. What this problem asks you to do is write a function, generate parentheses, which will return all of the valid strings that use that number of parentheses. So their example is if you're given the number n, you'll return all of the valid strings that have 3 parentheses. And when I say valid, what I mean is that they have a balanced set of open and closed parentheses. So 3 open, 3 close, that's a valid set. This parenthesis closes that one, this one closes that one, and so on. Or we could say something like this is a valid set, but what would not be a valid set would be if we had, say if we began with a closed paren, or if we had open, close, close. Things like this are not a valid set. So this is what the problem is asking you to do. I don't have my solution right here because I wrote it in a different browser, so we'll just have to look at my submission history to see my submission. And my historical submission is, this one. So I'm going to use recursion. Here's the program they asked me to write, or the function they asked me to write, generate parentheses. And I just have this special case here to say if n is 0, then just return a list with an empty string. And that special case just felt a bit easier to me to write than to make this more general. My recursive function is going to return empty strings for all the invalid parenthesis lists. And so I just filter out all of the empty strings, which is what you see with the list filter right here. I call my recursive function with a couple arguments that I'll talk about, and then it will give me back a list of all the valid strings plus all the invalid strings as empty strings, and I filter out the invalid strings. And so because I've written it that way, I just had to add the special case for, well, what if n is 0? So this function proc, I probably could have thought of a better name. I don't know why I called it proc, but anyway. What it does is it takes the count for the current number of open parentheses and the number of closed parentheses that you haven't used. So what I want to keep track of here is when you use a closed parenthesis, it's valid to use it if you have a previous open parenthesis. Then also what I'm going to take as an argument is the result, and this is going to be a list of valid strings that I build up whenever I find one. And I'm going to take this argument so far, and this is the string that I'm building up so far as I progress down the recursive path or track. So let me talk about how this works. The base cases come first. So if the number of current open parentheses is greater than the number of closed parentheses we have left, we're just going to return the result. In other words, you can't build a valid set of parentheses with this, so just go ahead and return whatever the result is, because we're not going to be adding anything to result in this case. So that would be like, okay, we're given 3 as our in, and if we have more open than closed left, so here we have 1, 2 closed, and we have 2 open. 1, 2. So we have more open than we have closed left. I guess at this point we'd have, there we go. Now we have more open, 1, 2, 3, than we have closed left. So that's why we can't add anything there. Another case is if there are no more parentheses and none are open. That means we've used up all of our closed parentheses and we have no open parentheses currently, then we're balanced. So we can return whatever the result is, concatenated to what we have so far. So like the string we've been building up so far is valid, so just add it to the end of result. The next recursive case, or sorry, the next base case is if you've used all your closed parentheses, but you still have some open parentheses left to use. So in this case, we would just return the result that we've been building up. Yeah, nothing left to do there. That's a kind of similar case to the previous base case we looked at. And as I'm talking through this, it's occurring to me that it may not even be possible for some of these base cases for us to land in them, but I can experiment with that more in a second. This final base case is you've closed more parentheses than you've opened. So whenever we close a parenthesis, I just decrement the open count. And if it ever gets below 0, that means we're in this condition where you closed one more than you should have. So when I open it, I will increase my open count, OC to 1. When I get a closed parenthesis, I'm going to decrement that to 0. When I get another closed parenthesis, I'm going to decrement that to -1. And then I'll know to fail in this case, where my current open is less than 0, in which case I'm just going to return out the result I've been building up. And so here is the recursive case, where I build up the result in the so far strings that I've been talking about. So you can do two things, basically, with the parentheses. You can either add or close a parenthesis. So if we just think about it like, okay, we call proc, like we want to add something to our string. If our so far string is, open, then what we could do is either add another open parenthesis, or we could add a closed parenthesis. And then, from this branch, we could either add another open or another closed. And from this branch, we could add another open and add another closed. So I'm just going to recursively build up those two branches by calling the proc method twice. We're going to call it by incrementing our open. So this is saying, okay, we're going to consider the two paths. One where we add another open parenthesis. We have the same number of closed parens left. Our result is the same, and our so far string builds up with an additional open parenthesis. And then I'm just going to put a comma in between it, so that I build up this result string with an easy separator that I can just split on later. And finally, I'm going to concatenate to this the call of another recursive call of the proc function with one fewer open parenthesis. I'm decrementing the open parenthesis count because what this proc call represents is the right-hand branch where I'm adding a closed parenthesis. And so to add a closed parenthesis, I'm decreasing my current open count. I'm decreasing the number of closed parens I have left by 1 because I'm using one of them. The same result, and then I'm adding a closed paren to my so far function. And so this winds up being not fast. It's something like 30 to 40 percentile for speed, but there's a kind of trivial optimization I made to it that made it go significantly faster, which I'll talk about in just 1 second. In terms of optimizations, usually with these recursive problems, I'd want to lean on memoization. So this is 20 percentile for speed. I'd want to lean on memoization, which is storing my recursive input and output so that I don't have to, repeat operations that I've already done, essentially. But I can't really use memoization as I've written it because one of the arguments to my function, well, two of them, result and so far, are getting built up over time. The result string is just building up all the results I have, and so far is building up what my answer is. So I'm never going to call proc with really the same input, the same inputs every time. So I don't really have a good, at least so far as I know, I don't really have a good solution for memoization or a good opportunity to do that. If I could do that, I assume it would really speed things up. Let's see, that is not the solution I wanted. Where is my other submission? It should be my second submission. I suppose third. Oh no, this is a different problem. Oh, excuse me. My terribly high production value. If I edited problems, I would edit this difficulty out, but I don't want to. So, yeah. So the optimization I made that increases it from 20 percentile speed to 40%, or sorry, to 60 percentile speed, which I felt was good enough to just leave it at. It's right here. I'll show it to you, I suppose, right now. But what I did is just change how I'm concatenating the strings. So in my original submission, I was just concatenating them with the plus sign. So I was just saying, okay, concatenate the left-hand side plus a comma plus the right. And so I just modified this slightly to use a format string instead of plus. So I just said, okay, format string, one string here, the comma here, and then the other, like the closed parentheses part here. And so that jumped me up to 84% in this run. I've seen like 67 or 80%, something like that, previously when I ran this. So really that's just, I guess, a bit of a grain of salt for you to think about kind of the percentile speeds, because I really didn't change anything about the algorithm, just kind of an implementation detail of how I was concatenating strings, and it causes a huge shift in performance. So I would say this algorithm is kind of equally smart as the one I just walked through. I mean, it's almost exactly the same except for how I concatenate strings, but it's a big difference in terms of performance. Anyway, yeah, that'll do it for me for this video. If you're interested in seeing LeetCode problems solved and walked through, then subscribe to the channel, click the like button if you like the video. Let me know in the comments if you're watching. I'd appreciate it. Thanks for your time. Bye-bye.